Hey guys, so we're back again in this Pandas 10 minutes to Pandas documentation reading series. And this is the first time I'm reading this as well, as I've mentioned this countless times by now. So we ended up with pivot tables in the last video, and now we're going to start time series. So let's read it. Pandas has simple, powerful, and efficient functionality for performing resampling operations during frequency conversion. For example, converting secondly data into 5-minutely data. Okay, so basically it means that Pandas has an efficient method of converting. Say if you have given it data which varies, which is for every second interval, it can convert it to say into intervals of 5 minutes. This is extremely common in, but not limited to financial applications. You can guess so because stock market, uh, it can vary in seconds, so it might be in use there. So let's start off by doing this uh, trying to understand what this means. So pandas dot date range, and the starting is at 1st of January 2012. So if we print out range, we get 100 periods, and the frequency is per second. So I reckon it's increasing with every second, and there are 100 seconds. Yeah, so that's that. So now let's look at this. So here they are creating a pandas series with random integers, and the integers are of length. The number of integers is the same as the length of range, because otherwise the number of columns and the index wouldn't have matched. So here we have our TS. Yeah, it has 100 columns, so it's not showing us everything, and we can. Okay, so now we can do this resample 5 minute, and what we get is, let's do this. Yeah, so it's resampled it for every 5 minutes. We do the sum now. We get the sum to be 2,400 24,656. So yeah, basically the data which was per second has now been converted to uh, every 5 minutes. I guess, but is there a way to print out this? I'm not quite sure about it. This is the first time I'm exploring this as well. Maybe doing something like this. No, doesn't work. But still, we get the idea. So now, frequency 50, data type int 64, yeah, standard stuff. Now let's look at time zone representation. So again, they are defining a RNG variable, which is pandas.date range, and this time it's 3/6/2012 at 0, and period 5 frequency TD means day. So periods 5 would, I guess, increase the day by 1. So yeah, 2012, we have the 6th of March, 7th of March, 8th of March, 9th of March, 10th of March. So basically you can see that even when the input was in this format, it has been converted now to this format. So the standard format in for dates in pandas, which is year, month, and day. Now let's try this. Another TS, which is a pandas series, and this time as well, it's taking random values from rand n, which is random values from the normal distribution, and we can print out TS. Now what does this do? TS dot TZ underscore localize UTC. TZ, I reckon, is time zone, and localize means most probably converting this into the UTC time zone. Yeah. So now it has the time zone as well here. UTC is the universal time zone, so I guess that's why there is no addition here. If Can we do GMT maybe? Yeah, Greenwich Mean Time, same. IST, does that work? No. I guess there are other values which need to be passed. So let's keep that at UTC right now. Okay, converting to another time zone. Okay, so this is how we convert. and yeah, we can just use this and it prints out. Here now we have the 5 which indicates -5, which indicates it's 5 hours behind the UTC, and the pandas time zones list, and hmm, okay, so this should copy, this should work, I guess. If I just do this, didn't do anything notable. Hmm. Let's just take something like say Brazil West. Yeah, it does work. So now let's look at converting between time span representations. So again, RNG variable, let's just print it out. So it's a date time index, 5 periods, and the frequency is now monthly. So it's going to increase by 1 month every time. And now you can see something very interesting here. 31st of January, then the 29th of February, then the 31st of March. So it takes the last date of every month automatically. And now again they have created a TS variable, which is a pandas series, and when you print that out you get another random list from the normal distribution because they are using rand n. The index is set to this new RNG, and you can just print out TS, which I have done here. And now PS2 period, so let's try that out as well. um hmm so basically the days got removed and now we only have the months. So what did this do? I didn't quite get it. Hmm. Let's just look at 2 period in pandas. Cast to period array indexed at a particular frequency converts date time array index to period array. So okay, so the frequency was monthly. So is that why it converted it to months? I'm not sure. Hmm. Converting between a period and a timestamp enables some convenient arithmetic functions to be used. Converting between time span representations is right here, but I'm still not able to get it. Let's just read this once again and look at the example. So they had this y and this panda to date time this stuff, and periods index is this, date time is monthly, df dot index to period m. So it converted it to monthly periods, and yeah, just like I thought, the days and the other stuff has been removed. So let's just try. So maybe the standard is monthly. Is that so? How about yearly? Is there some option for that as well? Yeah. So now we get it. When we convert to the monthly period, all other information besides that of the month and other subsequent bigger intervals like years are kept. So now let's look at PS2 timestamp, and what does that do? So to timestamp, I guess we'll have to look that up as well. Hmm. So basically, you might be wondering If I am reading the documentation, then why I'm going to another piece of documentation? That's just because this is a intro documentation, 10 minutes to pandas basically, and these are the more in-depth documentation which are provided. So cast to datetime index of timestamps at beginning of period. Okay, so the frequency is desired, you can set it at beginning of period. Okay, so if I change the frequency to M, first of all, let's try to get understand what this MS frequency even is. So let's just look up frequency MS in file pandas month start. Okay, so now we get why it's starting at this 0101. So it's just now at the month start instead of the month end like it was here. Yeah, that makes sense. So there must be a list of the frequencies which pandas has. I'll try to look for them as well. In the following example, we convert a quarterly frequency with year ending in November to 9 a.m. of the end of the month following the quarter end. Okay, so basically they are creating a new variable PRNG, period range, I guess. And if we print that out, we can see it's okay. So it's quarter wise, 1990 quarter 1, 1990 quarter 2, 1990 quarter 3, and so on. And quarter November frequency and okay, and now we can just use this TS variable. Sorry for any background noises, there are people in the house as well. And now it's given all of them a random value here. You can see all of them now have a random value associated with them. And now what they're doing is, let's just try that out. They're, no, I need to print out TS. Yeah, so earlier our TS was something like this, and now they added an index. So as frequency m comma e plus 1 as frequency h comma s. Okay. Hmm. So I get the m part as frequency m, e plus 1 might be these days because everything is a 1 here. But to really understand this, I guess, okay, we convert a quarterly frequency with year ending in November to 9 a.m. of the end of the month following the quarter end. 9 a.m. of the end of the month following the quarter end. 9 a.m. Okay. So it's just converted all of these to the end of each quarter. So the first quarter ended in the month of March 1990. So it's converted them to the first 9 a.m. which comes after that. So that's what's happening. The 9 here represents the 9 a.m. and yeah, that's what it is. Now let's have a look at categoricals. Pandas can include categorical data in a data frame. Okay. Yeah, so this is quite similar to what we have already looked at. So this is sort of like you've given it an ID, a dictionary which converts them into these data frames, and now we can convert the raw grades to categorical type. Okay, so df grade is equal to df raw grade dot hash type category. Okay, so let's just do this, and now you have created a new data frame, a new column grade which has taken the values of raw grade. But if you just print out the entire data frame, yeah, so it just added a new column grade and it took all the values of raw grade as category. You can also rename the categories to more meaningful words. So let's try this out as well. What does it do? And now let's have a look at DF. So what it did was convert the A to very good, the B to good, and the E to very bad. Okay, so it just took the first occurrence of a particular word and gave it the first value in this list, and all repetitions were assigned the same value, while the second occurrence of a new character was given this good and then very bad. Makes sense. You can also do something like this. Okay, reorder the categories and simultaneously add the missing categories. Methods and the series.cat returns a new series by default. Okay, I missed the D, I just spotted that. So now let's just print out df. Doesn't seem all that different right now. So what's exactly different here? Hmm. Reorder the categories. So it's the same as last time. So rename the categories, reorder the categories, and simultaneously re-add the missing categories under the series.cat thing. So I think it's the same thing being done by two different methods, because the output for both of these is the same. But now in this method, the other one, we have more categories to our use. So if we try to get df grade just that, we can see, yeah, we have more categories to our avail. So maybe we can add different characters in those categories will be saved in the backend. Okay, and now df does sort by grade. Oh, okay. So the order was important here because very bad was given first, and now it has set the categories into this order. So now when we use the sort values operation, it will do this thing where very bad is now the first thing. We can just take another example here. So this should now keep, yeah, very good at the top. So now we understand what the set categories does. Sorting is per order in the categories, not lexical order. So this categories is the criteria for sorting. We can also just do the group by and have a look at size. So doing this gives us the number of occurrences of very good, bad, medium, good, and very bad. And now we are reaching towards the end, which is the plotting parts. So let me just see how long the video is now. Um, okay, let's just stop here for now then, I guess, and we'll continue the plotting, the matplotlib and all the other parts in the next video, and we'll hopefully finish it all in the next video. Thank you guys for watching. As always, I'll have all the links in the description, and you guys can watch some other tutorials as well. And as I've mentioned numerous times before, I'm a beginner as well. I'm reading the documentation, as people always say, read the documentation, read the stuff. It's very well written, but it's very scary to get into at first. So I thought it would be a good idea to maybe read along with you guys. I'm figuring out most things, as you might have seen. So I must say the documentation is very well written, because say if I had stopped at this example thinking, oh no, I'm not getting it, and not just come down here and see, oh, what it really did, then I'd have just left this stuff. But the documentation is very well written, and I must commend the writers of the documentation. Thank you guys for watching, and hopefully we'll finish this 10 minutes to pandas gone long in the next video.